Welcome back. We explore periodicities and annualized yields in fixed income securities, unlocking key insights for maximizing your understanding of yield measures. In the previous lecture, we saw the features regarding fixed income analysis that a trader or an analyst or a financial advisor need to know when considering buying or selling a bond, investing in a bond, or pricing a bond, for instance. Remember, these feature effects, specifically maturity, coupon, yield to maturity, and convexity, are a very important area in fixed income analysis that revolves around the topic of risk, and in particular, the topics of modified duration and convexity adjustment, that we're going to see in the next lessons. In our previous lessons, we described as frequency the number of coupons paid during a year, and I even called it periodicity. It isn't completely correct, but to a certain extent it is, since frequency matches periodicity, typically. In this video, we're going to talk about periodicities and annualized yields, and we're going to elaborate with regard to effective annual rates, how periodicity affects them, what we should do for zero coupon bonds, and at last, the convention for conveying bond yields called bond equivalent basis. And we'll be using this formula for periodicity or compounding conversions. Before we jump in, don't forget to grab the must-haves, the spreadsheet, the notes, and the slides. Investors, traders, and analysts need standardized yield measures for comparing different options and accordingly use annualized yield measures to allow for these comparisons. Moreover, for securities with maturities longer than 1 year, investors want a compounded yield to maturity. To annualize and compound yields on a fixed-rate bond, we have to make assumptions about the interest periods during the year. This assumption is called periodicity. Now, let me share my screen with you. Remember the Carb Fuel Aviation bond we already saw? Let's focus on another quote we've just gotten from another dealer, 103.21. Recall what we said about fixed income securities quotes? They are flat prices. This is a flat price. We are on the hypothetical settlement date of November 12th. Remember that I'm using the convention of day, month, year to express dates, as you see them on my Excel sheet. For this quote of 103.21, we get a yield to maturity of 2.2504. Again, what is this? It's the discount rate that makes the sum of the future cash flows in present value equal the full price. You can notice that here on the right side of the sheet, I've recreated the hand calculation we did before by using Excel's GoSeek function. We got 1.1252%. This is the rate we got by iterating the solution with GoSeek. This is semi-annual, because these are half years. These periods are half years. The discounting occurs on a semi-annual basis. What we get by using Excel's formula is 2.2504, which is 1.1252% doubled. This is the convention for expressing bond yields, and is called bond basis yield or bond equivalent basis. If we had another bond with a coupon frequency of 1, meaning 1 coupon per year, could we compare it to our cash bond? Not if we want to draw some conclusions in terms of their yield differences, because the cash bond compounds 2 times per year, being semi-annual, whilst the other bond only 1 time per year. We need to transform the bond equivalent yield of 2.2504 into an effective annual rate. How? I've done it here in 3 different ways. Basically, applying the equation at the top of our sheet in cell E36. using the Excel's future value formula in cell F48 and the effect formula in cell G48. The latter is basically the equation at the top. The former explains what we're doing. We're compounding a yield after 1/2 period at the same rate. So, a semi-annual rate of return of 1.1252%, 2 times per year, generates the same return of a 2.2630 rate of return, 1 time per year. This is the effective annual rate, which has a periodicity of 1. We can make comparisons now among bonds that have different periodicities. Why is the effective annual rate greater than the bond equivalent yield? Because it compounds 2 times per year. We get interest on interest. The two most common periodicity globally are 1 and 2, as most bonds, like in the US or the UK or Europe, make either annual or semi-annual coupon payments. Again, to reinforce, in our spreadsheet, the yield per semi-annual period was 1.1252%, and its semi-annual bond basis yield or bond equivalent yield is 2.2504%, whilst its effective annual rate is 2.2630%. Again, for instance, if a bond yield is 3% per semi-annual period, its annual yield stated on a semi-annual bond basis or bond equivalent basis is 6%. What about zero coupon bonds? We still haven't seen them. A zero coupon bond is a fixed income instrument where there's no coupon payment. All the interest payment occurs at maturity when it redeems. At redemption, the investor receives the principal value, namely the price paid when issued, for example, plus all the interest accrued during its lifetime. The periodicity of the annual discount rate for a zero coupon bond is arbitrary because there are no coupon payments. To see this, we can take a look at an example. Consider this 5-year zero coupon bond priced at 90. If we assume annual compounding, we simply discount the redemption value of 100 for 5 years at the rate of 2.13%. If we assume semi-annual compounding, we have 10 half years and we get 2.118%. If we assume quarterly compounding, we get 2.113%. But if we then turn these bond equivalent yields into effective annual rates, we always get 2.13%. The reason is there are no coupons. What if we want to convert a quarterly bond equivalent yield to a semi-annual one? Namely, we have a bond with quarterly coupon payments that we want to compare with another one with semi-annual coupon payments. One way to do that would be to turn both into effective annual rates and then compare them, right? Effective annual rates have a periodicity of 1. We have another tool to do this, and that is to convert an annualized yield from one periodicity to another using a periodicity conversion. To show this, let's have a look at the general formula to turn an annual percentage rate for m periods per year to an annual percentage rate of n periods using this equation. If we have a bond with quarterly coupon payments whose yield to maturity is 3.5% and we want to compare it with another bond, but with semi-annual coupon payments of say 3.75%, then by converting the 3.5 yield to maturity to semi-annual periodicity of a yield to maturity of 3.5153%. As we wrap this up, consider that the rule for periodicity conversions is that compounding less frequently at a higher annual rate is equal to compounding more frequently at a lower rate. Remember to work on the questions at the end of the lesson to reinforce your learning. And if you haven't done so yet, be sure to download the slides, the spreadsheet, and the notes. They'll be invaluable for your study and review. Okay, guys, this will do for me, and I'll see you in the next video about bonds with embedded options and yield to call.